Hello, statistics people. This video, I'm going to be talking about t-sample size and the t-table. So this one should be a pretty short one. I'm going to be using our favorite example from class the other day. So for these top questions, I want to refer you to the video I made on solving for confidence interval. I feel like I do a good job of the wider, narrower thing in that video, and I show you guys kind of a different way to think about it. But in any case, as we decrease the width of our interval, our confidence must also decrease. Okay. Cool. So really what I want to know about this is this sample size question. I'm going to type that in here. I want 90% confidence. I've typed the S from our problem here and the desired margin of error given in the problem right there. And what confuses me about this workbook is why there's two n's, right? This is the n you want to grab, right? That's the n that gives you 229 there when you add 1 to not have half the people, right? Okay, so then what do? Use the n from step 1 with a t n minus 1 distribution. So that's our t-score for this new sample size. And that would be the n needed, I guess. I'm not sure what's going on there. But this is the number you put in. And that's the end of the problem. Yeah. So this is the number you need right there. That one, that one, that one, that one. Okay. So just so I can cram in the t-table into this video, let's look at a few things here. So back to t-sample size. So 229, that was our value, right? So yeah, let's look at a t-table. So if I'm testing things for a t-table, right, let's compute a t-score. Like say I didn't want 90% confidence interval. I wanted to know what t brackets 90% of the data, right? So I want the t-score that gives me 90% of the data would be below. So if my n is 229, my degrees of freedom are 228. I want probability probability outside t. Let's put a 0.9 there. Area outside t, so that's the t-score I would need for this huge amount of degrees of freedom. Let's look at 0.95. Okay. So area outside t. I see. So I could make that a 0.05. And things would start making a little bit more sense. Yeah. So this is the area outside, not the area inside, like with this guy. Oh, no, same thing over here. Probability inside the interval, right? So you want to reflect those when you're calculating, right? If I want 95% inside, I put 0.05 outside. So we could ask, like we could ask things like, what area is outside of a t-score of 1? 30% of the data is outside of a t-score of 1. What percent of data is greater than a t-score of 2? About 2%. So just play with this. Note something else here. If I bring this down to like 10 degrees of freedom, t-score gets bigger. probability that the absolute value of t is greater than 1, so greater than 1 or less than -1, that got a little bit bigger. So what's happening? The spread is increasing as I decrease n. If I take it all the way down to 4, you can really start to see it dramatically, right? If this is 1,000, these get a little bit smaller. If this is 2, they get a bit bigger, right? Okay, so I hope that was a good exploration of this kind of stuff, right? The idea is all still relative to t-scores, so you got to compute relevant t-scores, right? Um, yeah, yeah. All right, so I think I'm going to call it there. All right, one more off my list. Coming back at you with 1p, 2 mu, 2p, 1 mu hypothesis test, and 2 mu hypothesis test and confidence intervals. And then I think I'm done for the day. All right, guys.